So I'll be talking about clean architecture and the theories of that first, and then we'll transition to talk about my framework that I built, Flood, and how I use clean architecture to make Flood as useful and powerful as it is today. So the first question I have for you guys is, which of these software architectures looks easier to understand, maintain, and extend? Anyone going for the left side?
You want the left? Kind of like the left side. It's more artistic.
It's more artistic, is that what you said?
Yeah.
Okay. That's one idea. Anyone think the right one is better? Yeah. So let's talk about the situation that happens. So we tend to add code in order that we come across problems. So an example of that could be that we start with some basic UI. We come up with like a wireframe or whatever, and then we want to integrate it with the database. So the UI now depends on the database. Then we need to add authentication so that users can only access their specific types of data. And we need to add a login and a sign-up page, and so now the dependencies are starting to become a bit more complex. We then need to update the UI whenever the database changes. So now maybe the database depends on the UI itself. Then we need to add some caching. So the database depends on that, and the UI maybe also directly calls the cache to get some data. Then we need to add some local storage in case the device goes offline, and we need to figure out whether they're connected or not. We see more dependencies, and maybe we need to add some reaction to the user's connectivity. So if the UI can display whether the user is online or offline. So you can see this becomes a tangled web, and this is just for like a small little example. Like for actual programs, you would have a much more complex web if you add code in the order that you come across problems. And so we need to think about the approach that we take in regards to code architecture. So you guys can see my mouse. So on the right here, we have a little diagram, and we can see how the axis over here is the lines of code written, and here is the time per additional line. So if you take a quick and dirty code approach where you don't really think about architecture, you just write code in the order that you come across it, you can see that at the beginning it's really, really fast. You're going to be able to quickly create your project. But then as time goes on and as you have an unmaintained architecture, you're going to quickly run into the problem where it takes longer and longer to add code because you have to deal with this huge web of dependencies and actually get everything
Let me
working
just
correctly.
interject here, because the quick and dirty code way can sometimes be useful as well.
And I will talk about the pros and cons for both approaches in the next slide. And on the other side, we have the thoughtful and clean code approach, where at the beginning, it's going to take some time to get started, and it's going to take a while for that payoff to actually make sense. But then eventually, if you are working with a really large project, it will make sense to consider a clean code approach, because it's flexible, it's built to be flexible, you can easily add or remove things as needed. And so, as like an example from my own experience, I worked at a job previously where I worked for a software government contracting company where they used this quick and dirty code approach where they had just hundreds of authors, coders working on one architecture. There was no clear architecture for the system, and this thing spanned hundreds of thousands of lines. And so making just the smallest little UI changes took a tremendous amount of effort. It took editing like 30 files to just get one little piece of text to change. Whereas when you're working on something that's thoughtfully and cleanly designed, you know exactly what the architecture looks like. You want to change something, it takes a few minutes. And the other issue with the quick and dirty approach is technical debt will start building up, where technical debt is the implied cost of future reworking because the solution prioritizes expedience over long-term design. So here's a quote from someone who's really famous in the clean code architecture industry. He's like a spokesperson for this kind of methodology. His name is Robert Martin. He's the author of this book called Clean Code, which I would highly recommend if you're interested in learning more about this. He says the only way to go fast is to go well. So we're going to talk about the pillars of clean architecture. There's 4 pillars, and we're going to dive into each one of these in this presentation. The first one is separation of concerns, where we want to divide the software into distinct sections, each addressing a separate concern. We're going to talk about the dependency rule, where we want source code dependencies to point only inwards. We're going to talk about abstraction, which is using interfaces to decouple implementation details, and then modularity, where we're going to organize code into independent, interchangeable modules. And so let's dive into each of these. So the first one is separation of concerns, which is we want to divide the software into distinct sections. And I feel like the easiest way for me to explain what these things are is just to give a list of what it looks like to not accomplish this and what it looks like to accomplish this. So don't do the following. Don't mix UI logic with business logic in the same class. If you have a class that updates. Maybe you have a class for a specific page in your application. You don't want this class to modify both the UI, the text, and then also connect to databases, open files, use the environment variables, because then if you want to change something, it becomes a tangled web within that one class. You don't want to allow data access code to directly influence UI. You're going to want to decouple that and abstract that so that maybe the data access code can provide just like a stream of data or a listener of some kind, and then the UI can use that listener. You want to make sure that the data does not actually know about the UI itself. And you also do not want to tightly couple different parts of your application, so that if you ever want to make a change, you don't have to consider 5 different other things that need to be changed. Each of those need to consider 5 other different things to make a change. And so an example of what this could look like in theory would be if you have a function that just has all these different things that it has to think of. If I want to change something, it becomes a hot mess. On the other hand, we do want to divide our app into distinct layers. We want to maybe consider having a presentation layer that handles just the UI. You can have a domain layer which just handles the business logic, and the data layer that handles specifically connecting to databases. We want to keep business logic separate from UI code, and we want to ensure each class only has one responsibility. And so what this could look like in theory would be that you have the UI on the very top, and the UI directly calls the business logic can then call the data layer, which can then individually communicate with the network or handle storage or anything like that. Everything has its distinct role. If you ever want to change how the SQL database works, you need to look just in this network interface. You don't need to go and dig into every single one of these functions that are littered throughout your code base. And an example of this, what it could look like theoretically in code, this is like some Java pseudo code that I wrote to demonstrate the problem here. On the left here for the don't, here's an example of something that I would see similar in my previous job where I had just the really, really messy spaghetti code, where one function had way too many responsibilities. It would try to handle performance here, where you would start some kind of like a stopwatch for performance. Then it's going to immediately call the UI to show a loading spinner of some kind. And then it's going to do some business logic and validation here. And if this fails, it's going to show an error. And then it's going to try to create a database connection. It's going to use environment variables over here. It's going to then try to generate SQL and then run this SQL inside this database. And then it's going to call this local storage instance to update the cache, and then refresh the UI. And if we're naive, if we don't think about the clean architecture from the beginning, this is maybe how we would intuitively write a code to add a to-do item in a to-do app of some kind, because this is how our brains think. We're just doing things one step at a time. On the other hand, if we try to split this up so that we think about clean code, we may want to have a class here called to-do UI, where all of this UI class is doing whenever you want to add a new to-do item is you just show a loading indicator, and then you call this controller, and you say the controller will add the to-do, and then you can refresh the UI once that's done, and then if there's any type of exception, you're going to show an error. So if you ever want to modify the UI code, you know you only have one location to modify, which would be right here. The to-do controller could handle more of the application logic. It could handle actually delegating its responsibilities to different things. Whenever you want to add a to-do, it can handle performance here. It can do some business logic. And then it can just call this repository, this storage system to insert a to-do into it. Notice that the controller doesn't know anything about SQL or anything like that. You just have an abstract class over here, and you let it handle its responsibility.
It sounds like Ruby on Rails.
That's why it's a renowned.
Yeah, are we going to refactor it?
MVC.
What was that?
Are we going to refactor it?
In what way?
Like, we can still refactor that because, like, we have stuff that, like, for example, stopwatch start, stopwatch stop.
Fair enough. You could do like
You could pull that out into
fair enough, yeah.
higher level class.
Yeah, that's true. Yeah, that's a good point. And you can see how the repository down here for the to-do repository, now this thing can handle SQL. And maybe a proper name could be like SQL to-do repository instead of my to-do repository. But everything has its distinct function. We're separating the concerns. If you ever want to modify the SQL, you know exactly where to do that. If you want to modify business logic, you know where to do that. And then UI logic over here, instead of this hot mess where you'd have to find every single function in the entire code base to modify, like how, we want to replace a stopwatch with something else. Theoretically, we would pull this out into a stopwatch or a performance service and use that there instead.
Question.
Go for it.
Can AI fix the left so it looks like the right?
Of course. It'll try.
In my experience, I've had, like, AI generally thinks like the left. That's what I've noticed in my own personal experience.
Well, in my experience,
It's getting better.
That's pretty good. Like,
Yeah, it's getting better. I use it all the
it'll
time.
probably
It's
do
much
something
better
like
now.
this, but it'll probably miss certain stuff. but most of it, like if you're already a good software developer and you say you just don't want to spend time doing this, you just tell ChatGPT, hey, do this. Even if it misses some stuff, you got the gist of it.
ChatGPT works good when you already know how to code.
Yeah.
Yeah.
If you don't know, you don't know what it missed if you're not a coder.
So you save time using it.
Yeah.
That's why I think like software jobs are still safe for now, because like it doesn't understand the big picture of things. If
If somebody doesn't know how to code and does ChatGPT, they won't be able to figure out why something's not working.
Hey, I made a snake game because I was testing some JavaScript.
So yeah, but like for my own projects or whatever, I like because I have experience with architecture, I will, you know, ask ChatGPT maybe like I have some specific SQL that I need help writing, then I could specifically give it this one class here, and the AI now has the proper context instead of generating something that looks like a hot mess. I try to give it the right context so it can work within the frame that it should be working in.
I mean, we could try it.
We could. That could be an exercise for later.
O1 Preview has been pretty good actually.
Has it?
Yeah.
I need to play around with that more. The next one is the dependency rule, where we only want source code dependencies to point inwards. And by the way, a lot of these rules, they kind of intersect with one another, so just to give that in mind, like we're going to hear some repeats as we go along here, but specifically we want to focus on how the dependencies should only point in one direction instead of all crisscrossing across one another. So what we don't want to do is we don't want to allow core business logic to depend on UI or framework-specific code. The reason for that is if we have business logic tied specifically to like Flutter, for example, React Native, or whatever it is, and then you want to maybe update the UI to have HTML, or you want to create a CLI app from your business logic, you're not tied directly to UI, and it takes a long time to refactor that out. Whereas at the beginning, if the core business logic does not have any dependencies, and then the UI depends on that, you can then create another dependency for your HTML or for your CLI, and it becomes a lot more flexible. We don't want to directly instantiate concrete classes from outer layers and inner layers. And so what I mean by that is that the domain layer, like your core business logic, should not know about Flutter, for example, or React. It should not know about the direct concrete classes from outer layers. And then we also don't want to tightly couple our business logic to external libraries or frameworks for the reasons I was talking about earlier. And so this is what it could look like if we tie directly a naively built app. We have business logic directly tied in with Flutter, with a specific type of REST API with SQLite instead of a more abstract understanding of a repository. And then if you ever want to replace SQLite with something else, you have to now mess with all of these other different systems in your application to get it to work correctly. And on the other hand, what we do want to do is make sure that inner layers don't depend on outer layers. So the domain should not know anything about the application or presentation or the data layer here. It should just be its own contained thing. We want to use interfaces to define contracts between layers, and we want to implement a dependency inversion where necessary. And dependency inversion essentially means that whenever we instantiate something in the domain layer, we want to provide it the dependencies that it should have. So an example of that might be easier to understand through an example like this, where what we don't want to do is we maybe have some kind of a cache here for inside of our memory, but the cache depends on the UI because we pass in a private to-do UI over here. And so if we ever want to save the to-do inside of the cache should not be also adding the to-do item inside the UI and refreshing the UI. That is a backwards dependency here. The UI should only be the one depending on the cache. And then here, the UI here is also depending on the cache. So you have like the circular dependency, which then becomes really hard to untangle later if you need to. And then the notification service here also depends on the UI for some reason. So if you ever want to notify the user that their to-do has been created, you then show a pop-up in the UI. And now everything's become crisscrossed in such a way that it's hard to isolate certain functionalities and it's hard to test things. Whereas on the other hand, what we do want to do is we want to, just like before, I think this is actually the exact same thing that I showed earlier, where the UI doesn't depend on a specific implementation of something. The UI just has a controller, and the controller doesn't depend specifically on an SQL repository. You can pass in any type of repository into the controller, and it's just going to call this interface and let the interface take care of the internal details. So that's what the dependency rule is. We then have abstraction, where we're going to use interfaces to decouple implementation details. So what we don't want to do is we don't want to expose concrete implementations unnecessarily. We don't want to force users to use SQL. We want to provide some kind of a generic interface that then any part of the code can use SQL, or it can use a NoSQL, or it can use anything else. We don't want to tightly couple components to specific implementations, and we also don't want to create overly complex abstractions that don't provide real benefits. So one problem with abstraction that we see a lot is, first of all, not using it, but also we can become overly complex with it, where it becomes more difficult to use than if we just hadn't done abstraction in the first place. And so a diagram of what this could look like if we're doing it incorrectly would be that the business logic is tied specifically to the SQL database. And then if your vendor for your SQL database ever becomes too expensive and you want to switch out to something else, you're stuck. It's going to become a huge refactor because now everything depends on this specific SQL database over here. What we do want to do, on the other hand, is we want to use interfaces to define contracts between components. We want to hide implementation deals behind abstractions, and we want to design to interfaces, not implementations. So what that looks like here is in the business layer, the business logic depends on just this interface of a repository. We don't care exactly what it looks like or exactly what it does internally, but we just want to know that it can save and retrieve to-dos, and then the data layer is going to implement that with a specific implementation. And so what this would look like in a code example would be, what we don't want to do is, if you want to add a to-do, you're specifically calling AWS RDS here, and you're using MySQL to sanitize some SQL. And then you're using SQLite for a local storage, and then you're using Auth0 for logged in users and stuff. You don't want to tie yourself directly to all of these concrete implementations. What you do want to do instead is you want to be able to pass in the dependencies directly into the class. And these dependencies here, they're just interfaces. You don't know exactly what they're doing. You let something else implement them. And then whenever you want to add a to-do, you just call this abstract class here, repository to add, auth service.getLoggedInUser, notification service.notify, and you let those things take care of
And
their
also,
workings.
it makes it a lot easier to test
Exactly.
because you can mock.
Exactly.
You know, you can mock stuff. So a repository, you can mock it. You know that it works because somebody else. Let's say another team's working on the repository code. You're going to assume that it works, right?
Right.
So you can just mock that and say, okay, repository add method or function, it works. So we just say, okay, we're just going to mock some data coming through.
Exactly.
From it.
And I touched on that a little bit here in the modularity as well, the final pillar here, where we want to organize code into independent, interchangeable modules. So what we don't want to do is we don't want to create large monolithic classes or modules. We don't want to tightly couple modules to each other, and we don't want to duplicate functionality across multiple modules with this tangled web here, or I was showing a picture earlier of one function that had just like way too much stuff in it. We want to organize things into independent modules. What we do want to do instead is we want to break our application into small focused modules, design them to be independently deployable and testable, and use clear interfaces between modules. So here we've been talking about repositories or storage interfaces, and you want to make it modular in the fact that you can use SQLite, or you can use Firebase, or you can use an in-memory cache. All of these things implement this interface, and then you can easily modularly just plug and play everything in to get your application to work exactly how you want it to work. Or if you want to test something, you can use an in-memory cache, but if you actually want to deploy it to production, you can use SQLite. If you want to have some kind of a beta deployment for your alpha testers or whatever, you can use some other type of system. Easily just plug everything in a modular way like a puzzle.
One real world examples, like in Ruby on Rails, you have active record, right? So basically, active record is used for database
That's what I was just thinking the whole time. This Ruby on Rails works just
basically,
like this.
you can just say .create or something like that, and you pass in the parameters, attributes.
And then you use whatever
You can create it in
database or whatever.
SQL or whatever database you're using, so you can actually plug and play different databases for the end.
It's like
Yeah.
an abstraction layer for the
Yeah, it's
the
so easy to
database.
use,
Yeah.
For the
like in
database,
that sense.
the storage.
So a code example for this would be, what we don't want to do is you have just like an instance of a storage service that is specifically tied to MySQL, because then if you ever want to mock this or you want to replace MySQL with something else, you have to do some major refactoring here. What we do want to do, we want to create an interface of some kind where we have like a save and a get, and then you can have different types of implementations of this with the internal details to be whatever you need them to be. And like you were saying, you can then easily create like a public class mock storage service, and then you can easily mock it and then test like that. Here's another quote from a guy, Martin Fowler. He's the author of this book called Refactoring. He says, "A good architecture allows for changes in business requirements without excessive rework." So pros and cons for clean architecture, like you mentioned earlier. There's pros and there's also cons to it. The pros are that We have enhanced maintainability. It reduces technical debt. It eases long-term code management. We have improved testability because you can facilitate comprehensive unit testing and mocking. We have increased flexibility. You can easily change features. Clear separation of concerns, where everything has a specific purpose, and if you ever want to focus on something to change, you know exactly where to find it. And then efficient collaboration. If you are working with a team of people, one person can focus on the SQL stuff, one person focuses on the UI, you're not having to work on the exact same functions and get in each other's way. Cons are that it takes a lot of time to get started up in the beginning. This takes a lot of planning and upfront work. There's a steep learning curve. This is not something that is taught really well, at least in my schools at JMU. This was not something that was taught to us, and so this is something I had to learn on my own. And if your team is not prepared for this, this could be something that takes a long time to get right. You can over-engineer a lot of things, which can add a lot of development time and unnecessary complexity. If you ever over-engineer something and you want to make a small little change, you may have to unwind the entire abstraction or redo it, which can take more time. It increases the boilerplate, which can lead to way too many classes to manage. And then there's also the performance impact, where if you have multiple abstraction layers, for something like that's touching metal, for example, you don't want to maybe add too many abstractions that take too long to resolve, because then it's going to impact a lot of things.
And also on the time cost issue, the reason why I said that sometimes the quick and dirty code approach is actually better, because if we look at all the code, like if you look at a startup, you look at their code, most of the startup code is just it's a mess.
Yeah.
Spaghetti, right? And the reason why is because time to market is more important than the quality of code. If you can actually reduce the
that works right
time
now, real quick.
it takes
Think
to
about how to
actually push
fix it
something
later
out,
or
yeah.
upgrade it later.
That's why, like, you look at startup code and it's a mess. But see, like, I've been through this, and like, I kind of know why it's a mess. I'm like, I don't criticize people for doing that because I know how it is. Like, look at load panel. It's a mess there too, because we were trying to push stuff out. You know, we weren't thinking about really. It works. We weren't thinking about code quality and stuff.
Right. If you're like trying to prioritize just getting into the market to get validation, you don't want to focus on this. But once you get that validation, I can imagine that you want to think about the long term at that point.
If you're an employee of a company, yeah, you can think about this. If you're like one of the owners, you care about the. You know,
Well, what if you not really? If
Well,
you're the owner,
right.
you want the code to be good first, so that when you fire that employee, the next employee can figure out what's
yeah,
going on.
I know. But if you don't release your product in time, all that stuff doesn't
Yeah.
matter. you
Yeah.
know?
All the investors, all the stuff that's outside of the code.
And the reason that this clean architecture was important for me was because I was building a lot of apps I was doing freelancing for mobile app development, and I just needed to prioritize speed. And between gigs, I had a lot of time to just work on creating my abstractions so that when I wanted to get my next client, I could easily just whip out an app using the modular approaches that I was talking about earlier, which...
Sorry, go ahead. I was just gonna say that this approach is actually really good for like government stuff, military. Let's say military doesn't have a tight timeline, whatever deadline. They just want to have the best stuff. They can spend time with this, but I think the best approach is actually to like be in the middle there.
Yeah, so like you guys are mentioning Ruby on Rails, it's designed with clean architecture in mind so that people who build on top of it can build fast, right? And from my perspective, I wanted to spend the time between gigs to build something that was highly abstract and highly abstract with clean code, so that when it was time for me to go, like my Ruby on Rails is flood here, so that I could then build fast on top of that, instead of having to deal with all these little things with Flutter, which we'll talk about here in a second. So for context, I don't think any of you guys have worked with Flutter. So Flutter is a UI toolkit built by Google for building natively compiled apps. It's cross-platform for all these different platforms. It's got fast development, flexible UI, native performance, right? It's a toolkit that you use to build apps, essentially. And so Flood is this toolkit that I built on top of Flutter. It's open source. It allows you to rapidly develop Flutter apps, and it provides a lot of different tools that you can use to quickly iterate and build apps fast. Examples here would be, and I'll dive into the examples here, so don't get too torn up here, but I actually want to show you guys the website for Flood first, as I think that's the easiest way to learn. So let me break this off and go to my thing here. So this is the website for Flood, and I'm going to try to break things. The purpose of this website is to showcase like the key features of Flood and what makes it so important, and obviously this is targeted specifically towards Flutter developers. And since none of you guys are Flutter developers, I'll keep it in a more general sense so that you guys can understand what problems it solves. So Flutter, it has the ability to be very customizable in terms of the colors and the fonts and stuff like that, but when you have too much flexibility and then you want to change a style of an app quickly, like this for example, it takes a long time to go through every single place in the code where you want to change the font size of this, and you have to find all 80 pages and to change font sizes or to change background colors. Whereas I just wanted to rapidly iterate on a design. I didn't need to be pixel perfect to a Figma design. I just needed something to work. And so I created a style module over here that allows you to quickly define a style, and you can define a style with different primary colors and background colors, and then everything in the app reacts to the style. Flutter is not built like the native web where you have like HTML and then CSS styles that HTML. Flutter, you have to be very specific on every single point. And so what I built with the style module here was something very similar to CSS, where you can build something in an HTML-like way, and then let the style then actually dictate how everything should look.
So they don't have something like CSS?
Not in Flutter, no.
Can't you like create a style sheet and then import it?
You cannot. There's a concept of a theme in Flutter, but it's very limited where you can't control things such as the padding around a widget or an element, if you're more familiar with web code. There's just a lot of different things. You cannot change the spacing of a list view.
So everything you put in, you have to specify.
You have to specify every single thing.
Is it platform? It's independent of platform itself. Different styles for the different platforms.
You could if you want to. There's like you can target specifically like a Cupertino styled dialog to show up or whatever, but most developers use just the material style, which is like Google's Android style, but also for iOS. So this style system is really nice for me. I can then build my HTML-like structure within my app and then just style different things for different clients. So if I have a login page for one client, I can make it styled to look like this. If I then want to copy paste the code for that login page, then I want to modify the style, I just switch up the style, and then it looks a little different, but the structure is the exact same. We also have responsive widget themes here. So over here, we've got these cards that you can easily change like the emphasis. You can make it so they're regular emphasis, strong, or subtle. And then you can notice that whenever you change the color of these cards, the text color also changes, and the outlines of this checkbox and this triple dot menu here, they all change. So everything's reactive. In native Flutter, you have to go and manually change the font colors if you want the background color of a card to change, which takes a lot of time. You have to check, is the background color too dark or is it too light to change the font to be this? I did not like dealing with that, so I made it so that any internal fields inside of a card will react to its background to automatically change. And then we also have a instant style verification with a style guide. I added this bottom URL bar over here that you can type in custom URLs, and then I have a style guide page which is automatically generated for you based on the style that you're currently using. And that way you can easily see what your style looks like in a variety of different contexts. Then we have the pond module over here, which this allows you to easily add modules or components into your Flutter app. So something I was noticing was whenever I was building an application and I wanted to add like a URL bar on the bottom of the page, I would need to go find the 3 different classes, modify them to add this URL bar. Or if I wanted to make it so that I showed an environment banner up here that says testing here for the environment, I would have to go and find the different classes and add that. And this was just becoming a headache when there's a lot of different things I need to do this for, like Crashlytics or analytics or pages or styles or whatever. And so I created this pond module here where I can just add 1 line of code, and the component then is able to register itself and then know exactly how to function itself. You can create your own custom components here if you want, and it's also designed so that it's really easily, you don't have to modify your existing project to get this to work. You just replace 1 line here. Instead of material app.run, you do pond app.run, and then it'll just automatically inject those components correctly. We have a port module over here for form creation, validation, and UI. One thing that you're gonna notice in a lot of applications is you need to show edit forms and you need to show create forms. And this is especially tedious if you have a type of object, like if I'm working on a to-do app, an app that shows you to-dos, you need to be able to create new to-dos, so show a new to-do form, and then an edit form, which is copy-pasting a lot of code, especially if you have validation, this asynchronous validation, and this can become a headache. So what I've done is I've allowed you to be able to create a port, which is in the domain layer. It's just a class within itself, and you can create different fields here. So here I have an email field, which is a string field. It has a display name called email, and I want to make sure that it's never blank, and it is email. So I want to make sure that we validate for the fact that it is an email. And as you're typing things up here, and you show the keyboard, as you click on the text field, it's going to show you the correct keyboard layout for you automatically. And then here we have a password field, which has a display name of password. We also want to make sure it's not blank, and we want to make sure that it is a password. So here, we want to say that we're going to obfuscate the text as you're typing in here. And if you open up the keyboard on the phone, it's going to show you maybe suggested passwords. So I don't have to do all of this logic every single time I add a password field or an email field. I just define it in the domain over here, and then when I'm building this widget, I just call styled object port builder, and I pass in this login port over here, and it's going to automatically render the UI based on the domain objects over here. And it's really easy to interact with. This login button over here, whenever I click on it, I'm going to submit this form, and I'm going to check whether it's valid or not, and then I can easily pull the data from that form. So everything is streamlined, and I can easily create new forms and also edit forms as well.
Is Flutter the same as Expo? Is that what it does?
I'm not too familiar with Expo.
It looks very similar to React Native.
Oh yeah.
React Native is like HTML style code. Flutter is using Dart. Yeah, it's very similar to JavaScript. Yeah, and I mean, one benefit of Flutter over React Native, and you can maybe correct me if I'm wrong, but Flutter compiles directly to the platform binary code itself, so it runs on like your actual native performance. Whereas React Native, I think, has like a web view on top.
That's what Expo does, I think.
It compiles directly to.
You can compile to iOS, Android. So I guess it's like pretty much Flutter, Expo. They're just.
I guess they would be competitors, yeah.
Okay, because it looks very similar to, I guess, React Native code.
Yeah, I'm not too sure. I haven't messed with. I think Expo is a new thing, right? Is it relatively new? Oh.
No, I don't think so. I'm trying to remember myself what it is.
I remember when I was looking up Flutter. I've been learning Flutter for years and years and years, and back then there was no such. It wasn't visible, at least if it was existing back then.
I'm thinking it's probably at least like 7 or 8 years old.
Okay.
Probably older than that.
Yeah, because that's when we used it first, right? For the app.
You guys used Expo? Oh wow.
Yeah, for the trucking app we created.
To continue on over here, there's a lot of different versatile field types. You can create a lot of different types of fields where you can pass in like hints, for example. You can make it so that instead of strings, you can use ints or doubles for these fields. You can add dynamic fallbacks, so you can make a fallback that depends on another field within the form. You can do currencies or date times or colors. And whenever you automatically build the UI, it's going to take all of this into consideration to make sure that the validation is correct here and all the automated features would work for you. And so like if you were to click on this date time field over here, it's going to show a date time pop-up. And if you click on a color field over here, it's going to show a color selection screen. And yeah, everything is also completely customizable for you. And you can also override the UI as well, because the UI is automatically generated, but you can change the order of how you want the fields to show up. In the port here we have email and then password, but we want to maybe override it so the password and then email shows up for whatever reason. Or you can change it so that the email uses a different type of UI widgets than what Flutter will automatically generate for you. So a really versatile form system. Then we've got the drop module over here where you can simplify data management. It's inspired by a framework called domain-driven design, where we can define a model over here, and we can see how, here, let me restart this video. It's gonna take a second over here. Okay, well, I can do like this. So we have a model over here, right? And this model just consists of a bunch of different properties. And we can add validation to these properties, and we can see how this model is automatically going to be synced to the database. So whenever you can see that the name of this to-do is go on a run, and then inside of my database here, we can see that the name is go on a run. So everything is perfectly mapped to a database, and you can see how modifying the data on this model over here is going to automatically modify the data in the database. If you delete some data from your screen over here, it's going to automatically delete it from your database as well. So essentially it's a data modeling system where instead of having to manually call Firebase and call update or delete over and over and over again, for all these fields and add validation fallbacks, you just define a model and let it then integrate directly with Firebase or whatever database you choose. We also integrate directly with ports. So I was mentioning up here about the port module. The drop module integrates directly with it. So we have a data model described over here. This is just for data. But then if we want to create a new to-do, it's going to automatically generate a port for us from this value object. And then the port module allows us to generate UI for ports. So we can easily create forms for all of our different models and then generate the UI for those as well. So for me, to be able to add a new data type inside of an application that I'm working on takes a matter of a minute or so, instead of having to generate the data model, generate the form logic, and then generate the UI for that, which could take, 30 minutes to an hour or so. And it also allows us to easily react to data updates. So if we ever modify any of the to-dos over here, we can see that it's going to automatically update the list with this new to-do. This is a big problem for like React Native or Flutter to handle state management. So as you modify the state, you need to then make sure that all the pages in the app are aware that some new data has occurred. But with my system here, we just are using this hook called useQuery, where we're going to create this generic query. We're going to query from all to-dos whose users is equal to the currently logged in user ID. And then it's going to automatically update that page anytime that data ever changes, whether you're in this page changing the data or in some inner page changing the data, which simplifies Flutter development a lot. And then another thing that all Flutter developers are going to experience is releasing their apps. So by default, an inexperienced Flutter developer will need to open up the proper apps on their MacBook and on their Windows computer to generate builds and IPAs and manually drag and drop them into the app stores, which takes a lot of time. But this system over here allows us to easily define configuration using Dart code instead of another type of configuration language. And then you can run some CLI code over here to create we want to release our code for the beta channel. And we can see that the beta channel is linked to a pipeline here. On Android, we want to deploy it to Google Play. On iOS, we want to deploy it to TestFlight. And on the web, we want to deploy it to Firebase. And we just call the CLI command, and then it's going to ask us what version we want to set it to and what we would like to set the release notes to. And it's going to automatically take care of building it, linking it, setting up all of our keys correctly, and then deploying it to those stores. We also can generate security rules. So a lot of Flutter developers are going to use a database called Firebase because of how linked they are in the documentation. And Firebase allows you to create these security rules where you can manage how your data is secured. And this is using another type of language, some obscure thing that people aren't really familiar with. And if you ever change your data model, you have to remember to also go and change your security rules as well, which can become tedious and error prone if you forget something. And so this system here allows you to just define your domain data model over here. You can add some security to your repository over here, and then you can then call in the CLI the deploy command, which you'll see here in a second. And whenever we deploy it, it's going to go ahead and generate the rules for us, and then it's going to ask us if we like it. And if we click yes over here, it's going to then automatically deploy it to Firebase for us. So we can handle that whole painful process automatically. And then also native asset generation, where every single user who ever builds an app is going to want to make sure that their app icon is set correctly. And so instead of having to go manually create images and set paddings and set background colors and find the correct configuration files and everything, you can just use it with Flood here by just passing it with Dart code, what they're already familiar with. Just pass in the image, pass in a background color and some padding, and then run the correct command over here, which is native setup, and it's going to generate the app icon for you automatically. So I'm going to switch from this J icon over here to the Flood logo, and once it builds, we're going to see that we have the new logo for us over here by just running one command. And then there's also debugging here, which there is no concept of this in Flutter. This is something that you have to manually do every single time. But we have the ability to long press on the bottom left of our app to open up a URL bar. And then you can type in any URL that you want. And there's a specific _debug page, which allows you to view the logs of the device, which you can't do by default in Flutter. You can view the device files. You can view the different repositories from the drop module. And you can also reset the app as if it has never been installed. Things that you'd have to go and manually do yourself every single time if you wanted these features. But here you can easily do it by just adding one line to your Flood app over here. We have advanced log management, and we also can make it so that you can type in a query parameter of _debug equals true to a certain page, and then you're going to be able to see some debug statistics for how this page was rendered, what queries did it run, where did it get the data, what's the user's ID over here, and then it's able to help you troubleshoot any issues that you run across. And then there's some more things here, which I'm not going to get into, but essentially we can see how, for me, using clean architecture principles allowed me to easily create this whole entire system, and how I can create a data model, and then the port model is able to use that, and then the UI is able to use the ports, and how everything just works together in a very clean way. Everything has specific responsibilities.
I'm curious, with when you make an app, do you have some kind of back-end API that you call, or is that Firebase?
It's typically Firebase.
So Firebase, does Firebase handle background processing?
What do you mean?
Well, let's say you need to send a notification when user gets a certain number of points while he's not on the app.
Yeah. You can.
How would you do
There's
that?
something called Firebase functions where you can write like TypeScript functions and deploy them, and then it'll run based off like whether a document is created, or you can do it on a cron job schedule or just an HTTP endpoint.
Okay.
So yeah,
I've just never used it myself.
Yeah, and like another thing I have not on this website, but I've recently added is the ability to scan your different data models. And because Firebase functions only works with TypeScript, I've made it so that you can run a single command, and then it's going to scan all of your different data models and then create TypeScript definition files for you. So then you can have type safety for your different data models, so that you can call like user.name field instead of having to type in like apostrophe users or whatever, and then potentially have errors in that way. So let me plug this back up over here. So with that, I'll just quickly go through like the different pillars of clean architecture that I mentioned earlier, and showcase like how Flood approached this and what the benefits were from that I saw myself. So for the separation of concerns, the approach was that I had distinct modules for different functionalities. We talked about these already, and you can see how everything has a specific functionality. If I ever want to change the form logic, I know exactly where to go. If I ever want to change the logic for authentication, I know where to go. Everything has a specific purpose, and I know exactly where to modify that and extend that functionality if needed. And the benefits are changes in one module don't affect others. You can test these in isolation. Developers can work on different modules simultaneously. That's not something I've had to need myself personally, but if I ever did want to get more developers working on this, then it would be easy for them to know exactly where to go. And then modules can be easily replaced or upgraded independently. For the dependency rule, the approach that I took was I forced users who used Flood to break their project down into 3 different applications, where they have a core project over here, which has their central business logic and interfaces. The app project is the Flutter specific implementation, which handle all the rendering, all the routes and everything. And then we had the automate project, which is specifically for the CLI commands that are helpful for developers. And you can see that the app uses the core, the automate uses the core, but the core is not aware of app, or the core is not aware of the automate projects. And so the benefits of this are that it maintains a clear direction of dependencies. The core logic remains platform independent. So if I ever wanted to replace Flutter with another Dart-based UI language that ever comes out, it would be easy to integrate that directly with my project. And then it's easier to adapt to different platforms, and it simplifies testing of the core business logic. For abstraction, the approach that I took was I defined abstract interfaces in the core project, and then I implement concrete versions in the app project. So the core project would define something like a cloud repository, and then the app project could inject, hey, whenever you see the word cloud repository, use Firebase. But maybe my automate project could use a local system for that kind of repository. So it was very flexible to the different changes that I had. I can use Firebase, I can use AppWrite, I can use any type of system because I can easily plug in the implementations that I wanted to use. And the benefits of this are that it decouples business logic from specific implementations. You can easily swap implementations. You can facilitate testing with mock implementations, which I use a lot throughout my code base. And then it makes it easier to maintain and scale, since if I ever want to change the Firebase logic, I know exactly where to look for Firebase. And lastly, we have modularity, where the approach that I took was Pond, which is that system that I showed earlier, where you can easily just add one line to add all its functionality into your app. And so the benefits of this are that it promotes code reusability across projects. I can easily just copy paste this in my next client's project, and I just get a huge amount of functionality right off the bat. I can simplify complex applications by breaking them down into manageable parts. I can enable easy customization and extension of functionality. I can improve maintainability by isolating changes. So if I ever notice a bug maybe in my form logic, I don't have to go scour through 8 different packages. I know exactly where to find that bug. And then I can also, if needed, facilitate parallel development by different team members. And so to end things off, here's a quote by someone named Sandro Mancuso, who is the author of this book called Software Craftsman. He says, clean code is not just about writing code that works, it's about writing code that's easy to maintain and modify. And that's all I have. Any questions?
It was good presentation.
Thank you.
Very detailed.
Thank you.
Like no questions.
Uh-oh. It's a really bad thing.